Hi, it's Miss Carpenter at Humble Pie Math. So today in our box we have, something very interesting. We have a smashed potato. Okay, so the reason we have that will become clear in a bit. So I've prepared a couple of graphs so that this can go a little faster for you. So the first graph that I have, I'm going to bring it up nice and close. We have it goes down this way, and you can see that it begins, or the B on the y-axis is going to be where the 8 is, but it actually begins back here. So what do we know? Well, the first thing that we know is this number right here, because this is 0, 8, x is 0, that means that's the y-intercept. So our y-intercept is where it intercepts the y-axis. So there we go, goes through the y-axis right there. Okay, so that means in our y equals mx plus b, we know b. What is b? B is going to be 8. It's the point on the y-axis where it goes through. So where does it go through on the y-axis? When y is 8. So b is 8 in this case. Okay, what else do we know? Well, we have a whole bunch of ordered pairs. So let's put those in. We have x, y. So our first ordered pair right here is -1 and 10. Then we have 0, 8. 1, 6, 2, 4, and 3, 2. Our ordered pairs tell us where each point is on the graph. Okay, so now we need to find our slope. Slope, we will remember, is when you have your x values and your y values, and you find the difference. So, I'm going to move this guy right over here. Hopefully you can still see it, so that I can write over here. So what's happening here? Well, we notice here it's going down by 2. Each time we have to subtract 2. Okay, so that's the change in y. So the change in y is going to be -2. But what's happening with the x? Well, let's see. It's going up by 1. And this is a familiar set of ordered pairs that we often see. Oops. That's not what we want. We want change in x. Okay, my brain is growing. Okay, so the change in x is going to be 1. Okay, so we know that we can change this into a simple equals -2 as our slope. M is -2, but I'm going to leave it as a fraction, because when it's a fraction, it's easier for us to find it on the graph. Because if we were to start and we knew that b was 8, we could start at 8, and then we could say, okay, it's telling us to go down 2 and over 1. And ta-da, we're at our next set of ordered pairs, 1, 6. Then we go down 2 and over 1. Where are we now? 2, 4. We're going to go down 2 and over 1. And once again, we're at our next set of ordered pairs. That's why a slope is so helpful. Okay, so we've got our slope, we've got our y-intercept, and we can find use any of our ordered pairs in place of y and x on the y equals mx plus b. So again, it's y equals slope, the other part of the ordered pair from here, plus, and conveniently b is already there, plus b. So that is the equation of the line, and we're going to look at another example. Oh, before we go, we notice that the slope was negative. That means, reading left to right, that the line is going downward. The slope is negative, and that just tells us about the way that the line goes. The fact that it's a number 2 tells us how steep it is, how steep of a decline it is. So every time it goes down 2, it goes over 1. Okay, what happens when you have, we talked about positive and negative slopes. Now I want to show you a couple of specific cases that are a little different. So what happens when you have a straight line, which of course it has to be a straight line if we're talking about linear relations, but it either goes straight down or straight across. What is that? Well, let's have a look. If my line is going straight across, well, let's see what my ordered pairs would be. So let's pick a few. There's 1, 2, 3 ordered pairs. Okay, so this one, let's bring it nice and close. This one is on the x-axis, it would be 2, and on the y, it would be -3. So let's put 2, -3. Okay, what's this one? 4 and -3. Okay, what's this one? 6, because we always start with x, and -3. That's curious. So this whole time, y is -3. That never changes. Well, let's go 1 this way, because I'd like to know what my y-intercept is. So if I did one more value right before this, 6, 4, 2, it would be 0 for x, and y, of course, would still be -3. So my intercept, or my b, is going to be right here, and that's at -3. And what's my slope here? So let's try and figure this out. So my b is -3. If I plug in a couple of values, I can put each and every single time that y is always going to be -3. It doesn't matter what you put x as, y is going to be -3. And actually, in the end, my whole y equals mx plus b, everything is going to be gone except y is going to be equal to -3. So that's the one thing that you know here. And if I take 2 points, so let's take any of our 2 points. Let's take our 6, and where did I put my other marker? Our x value is 6 and our y value is -3, so we'll take that ordered pair, and we'll take this other one, 4 and -3. So we know that these are the x values right here, and these are the y values right here, because the y values didn't change. They kept staying exactly the same. Okay, in this case, we're going to bring this over here for a sec. In this case, we have our y values, the change in y. Let's say we call this 0.2, and this guy, let's use a neutral color. This could be our 0.2, and this could be our 0.1. So we're going to take, that means that's going to make this x2, and this is going to be x1, this is going to be y2, and y1. Okay, so let's take y2 minus y1. And that is going to be over our change in x, our change in x, which is going to be x2 minus x1. So what does our slope end up being? First of all, if you have 3, let's say you spent $3, and then someone came along and they said, I'm going to take away your -$3, because they're taking away your debt. It's like they added it. So when we have 2 negatives like that, it's like a double negative. Like if I said to you, don't not love math, I actually mean love math. So if you have a double negative, it ends up making it a positive. So -3 plus 3 equals a big fat 0. So if it's 0, and this is going to be 6 minus 2, which is 4, well, if you have anything that you divide 0 by, it doesn't matter if you divide 0 into 800 pieces or you divide 0 into 2 pieces, you're still going to be dividing 0, so you have nothing. So in this case, the slope, or our b value, in this case, b is 0. So when we say that not b. Ooh, I hope you caught that mistake. Not b. What is it? It's our slope. Oh, Miss Carpenter. Our slope is 0. I'm going to make it like that because I made another mistake. But see, my brain is growing. It's very good. Okay, so our slope is 0. Every single time you have a horizontal line. So when you have this horizontal line, I want you to imagine back to that weird analogy that I love that my students made up. A potato, if it's put right there on the line, how much velocity is it going to have? How much speed is it going to have? Well, it's going to have 0. It's not moving. It's just sitting there. So if you have a straight line and it's horizontal like that, the slope is 0. There's nothing moving. There's no rising up and down. You're just staying right there. Okay, that's the first example. Now what happens when you have a vertical line, like the pink one here? So if you look at this one and you take some of our values on this guy, let's go here, here, and here. So we can look at this and we can see that our values for that, I'm going to put it over here this time, X and Y. Let's start right here with our very first value. It's going to be X is 7 and Y is 0. Then we have X is 7 and Y is 3. Then we have X is, surprise, 7. And we have Y is 6. So what's happening here? This guy's going up by 3 each time. What's happening here? Nothing. There's nothing happening. So we're going to end up with a slope, or an M, of 3 over 0. Now when we get into more complicated, or I shouldn't say more complicated, when we get into more exciting math, we'll find out that maybe the definition undefined leaves us a little bit dissatisfied. But I want to come back to that another time. So we got our potato. The reason this was our object today is because if you can imagine that you put the potato up here and you drop it down the elevator shaft and it goes all the way down 5 stories below ground, you're going to end up with that kind of potato. So if this is going to happen, my students came up with a hilarious analogy that it would be like a very undefined potato, no longer any definition. So if you can remember dropping your potato from the top here, that's undefined. Just to finish off, let's take our values and put them in here. 7, 0, 7, 3, 7, 6. Awesome. So here we have an undefined slope. Here, the blue one, we have 0. Thanks. See you next time.